To introduce integration by parts, let's quickly look at an example where we didn't use integration by parts. This first integral was asking, when we had our denominator here with x squared plus 1, we would simply let this be our u value, and the derivative of that was 2x, so we would see that up there, and we know that substitution would have been a good method for this one. So we already have covered that one. But let's look at the second option and see why it's not good for substitution. We have x cubed and natural log of x. The derivative of x cubed is not natural log or anything close to it, nor is the derivative of natural log x cubed or something of the like. This is where we're going to need to use the integration by parts, and we'll refer to this formula all the way along. So to start this problem, remember, when you're doing integration by parts, it's a little bit odd to look at the formula, but eventually you'll just follow the pattern. You're going to start by selecting the u value. That means, what do you want to call u out of this entire integral? We can look for logs, inverse trig functions, polynomials, exponentials, or trig functions. Since we have a log in this case, we're going to look at our L or our ln of x as being our u value. So we would say u equals natural log of x. The derivative of that is 1 over x dx, because we took the derivative in terms of x. That means whatever is left over here, which I'll indicate by a squiggly line, this x cubed dx, will be called our dv. The reason it's the dv is, first of all, our equation calls for that. Whatever you pick to be your u, the leftover is the dv. But remember, dv means something was derived, and we took it in terms of x. So we're going to let x cubed dx be our derivative of some v function. Now that will require us to antiderive x cubed. What was the original function v if the derivative of v is x cubed? Well, by adding 1 to the power and dividing by that number, we can say 1/4 x to the 4th would be that function whose derivative is x to the 3rd. Now, from here, we simply follow this formula. We are trying to integrate our u, the natural log of x, times the derivative of v, which is x cubed dx. So we follow this rule. It will equal our u times our v. That's this u function times this v function. So we simply write them next to each other. Oftentimes parentheses can be helpful in order to keep it clear and not make it look like a minus sign or have things merged together. So this is simply our u and our v. Then the formula goes on to say minus the integral of v du, minus the integral of v, which again is this 1/4 x to the 4th, and our du, which is down here, 1 over x dx. So I'm going to put a times 1 over x dx. Now, what we see here is we have to simplify or kind of reduce our options over here, but we are going to be able to antiderive this. We don't have two types of functions anymore. So we're going to rewrite. I oftentimes, if I have a constant, I like to write it out front. So 1/4, I even like to write my x to the 4th out front. I'm just reversing those two because this way it doesn't look like natural log of x keeps going. You could still use parentheses if you like. I'm going to kick this constant of 1/4 outside the integral. And now I have x to the 4th over x, which will simply be x to the 3rd dx. Now this right here is something we can antiderive in our brain. So I will recopy all of the first part, u, v, minus 1/4 was their constant. The antiderivative of x to the 3rd is 1/4 x to the 4th. Multiplication is always the operation in between these. So our final answer for this antiderivative is 1/4 x to the 4th, natural log of x, minus 1 over 16 x to the 4th plus c. Remember that plus c is because we're doing an indefinite integral, and after all this work, sometimes we can forget that, so be careful. Some areas you can run into conflict or confusion, I guess you would say, is if you are anti-deriving, whenever you throw this little hook, the integral sign in there, notice how it stays in there until I've actually taken the antiderivative. Some of us tend to leave that integral in there. It goes away once you antiderive. It's also really important to be careful of this minus sign. Whatever comes afterwards, sometimes there is a negative constant and it will change it to a plus. But our formula must have that minus sign. So this would be your antiderivative. Now, something you could try just for fun, you could try to derive this and see if you get back to this answer right here. This would require the product rule. So while it doesn't sound like it will be fast, it's something you could try to prove to yourself that this really is the function, who is the antiderivative of x cubed natural log of x. I encourage you to try another one in your packet, and it can be found on the 6.11 exploration, page 62, roughly in your packet number 3. Here's an answer key, but maybe before you look at that answer key, go ahead and try it as it mocks the one we've just done.